All right, so I finished my general announcements. One other thing I did not mention is today is the last day to turn in the 4.1 textbook work as well as take the 4.1 quiz. I still have not everyone has taken the 4.1 quiz. That's why you're not getting them back today, but you will get them back tomorrow, and I'll be sure to post the answer key online as well. Yesterday, we did not finish problem 4.29. We got through parts A and B. The idea is we're trying to imagine an experiment where we're just testing the efficacy of a new fertilizer. And we started with what are the ways in which you can measure to compare tomatoes to decide, well, has the fertilizer actually done its job? And then also, what are sources of variation you can control? Okay, not to be confused with a control group. I tried to stress that a little bit yesterday, that there's a difference between a control and a control group. Okay, a control is a way in which you treat every single subject exactly the same way. That way you don't have to worry about that source of variation at all. Okay, everybody got the same thing. Okay, and we talked about how we could give every single tomato plant the same amount of fertilizers, the same amount of water, the same temperature, the same humidity. There's lots of different things you could do identical. Okay, that way, hopefully, if you measure a difference in the tomatoes, it's because of the new fertilizer that you're actually using on them. Okay, now part C asks, and I asked you all to sort of peruse these questions ahead of time because I knew I wanted to go through them quickly given the shortened period. Explain why there may be concern about sunlight and how to address it. Okay, I think a better way for me to phrase that question would be explain why the picture reveals sunlight might be an issue. Because I want to stress on the AP exam, it is not up to you to come up with subjectively creative responses. Okay, your response is going to be based off the given information. So I think it would have been a more direct question if I just said, based on the picture, why might sunlight be a concern? And the bottom line is, because you have the ceiling covered, but the sides not covered, where are plants going to get more direct sunlight? The sides. Okay, the plants that are sort of in the middle of the greenhouse, they're not as close to the uncovered windows. They're not getting as much direct sunlight. And I would argue amount of sunlight definitely has a relationship to how a tomato plant is going to be able to grow. So this is a source of variability that you cannot control, you cannot assign. If you have a tomato plant in this greenhouse, you can't randomly assign it to be in the direct light or not. It just is what it is. It's where it is in the greenhouse. So what you might do is run totally separate experiments. This is how you would address it. You'd say, all right, let me run an experiment on all the plants that are sort of around the windows, around the perimeters, and then I'm going to run the same exact experiment, but separately on all the plants that are inside. Okay, this is how you could block for sunlight. So I said tomato growth is likely strongly related to sunlight. To control for this variation, we would block, which basically means run separate identical experiments on tomato plants that are either near or far from the windows. Now, the next two questions are loosely related. Okay, I believe somebody in this class yesterday talked about color as being a response variable. I don't recall if it was this class or the other class, but I know somebody yesterday mentioned taste. I would argue that there's an inherent issue with taste, but there is a way to very quickly address it. Okay, describe a concern regarding the response taste and how to address it. Okay, so if I hire a professional taste tester to taste the tomatoes, I don't want them knowing which tomato got the new stuff and which tomato is part of my control group. I imagine a control group, a group of tomatoes that are just kind of grown under the currently recognized best methods with the currently recognized best fertilizer. That would be sort of my control group, something to compare my real test group to. Okay, well, when I hire some professional taste tester to rate these two tomatoes, bite into this one, bite into that one, rate them, I don't want them to know which tomato is which, because they might have their own subconscious bias when they bite into a tomato, knowing that it got the new fertilizer. Does that make sense? This is what we call blinding. Okay, so taste, which is subjective, is open to response bias, because if tasters know which tomato got the new fertilizer, they may subconsciously give these tomatoes a higher rating. So the way you address it is tasters must be blinded. And what that means in this context is that they would not know which fertilizer each tomato received. Okay, so the question that's left on the page is, can this experiment be double blind? I want to make sure that I'm going to do my best to explain this clearly. The idea of blinding is, do the subjects on the beginning of your experiment, whatever you're testing on, do the subjects, are they aware of the different treatments? Are they aware of the way in which they're being treated? Okay, that's one thing that you can kind of block to be single blind. Or on the tail end of the experiment, the people that are analyzing the results, I might block them from knowing when they're analyzing the subjects. I might block the people that are analyzing the results from knowing which treatment each subject got, because I don't want to worry about bias on the tail end. If you do either of those things, if you take efforts to make sure the subjects don't know what treatments they got, or you take efforts to make sure the people analyzing the results don't know which treatments the subjects got, if you do either one of those things, it's single blind. If you do both, it's double blind. Before I reveal the answer, I want to make it clear. If you do a double blind experiment, that does not mean nobody knows what the subjects got. The person running the experiment better know who got what. I say that because I've had students write that in the past. When they're asked, what does it mean for this to be double blind? And they write just some general statement about how, well, nobody really knows which subjects got which treatments. No, somebody better know. Otherwise, the experiment is completely worthless. Like, somebody needs to have a record of who got what. Okay, it's not that nobody knows. It's that the subjects don't know what treatment they got, and the evaluators, whoever's looking at the data on the tail end. Now, in this particular case, it's impossible for this to be double blind. I tried to phrase this very carefully. I said, if you take efforts to block the subjects from knowing what they know, or knowing what treatments they got, and you take efforts to block the evaluators from knowing which treatments the subjects got, that makes it double blind. This is impossible to be double blind. Can anyone argue why? Yep. It has to do with the fact that the subjects are inanimate objects. I'm not worried about a tomato knowing it got the new fertilizer and saying, I'm going to grow real big and strong for you because you gave me the new stuff. I'm not really worried about that. I don't need to put in effort to block the subjects from knowing what treatment they got because they're not sentient beings. Does that make sense? Okay. So, in a word, no. I'm being asked, can this be double blind? In a word, no. The subjects are tomatoes, which cannot be blinded. Okay. It can be single blind if the response is subjective, such as taste or color, and the evaluators are not told which fertilizer each tomato received. Again, that was kind of relating to the previous question. Let's imagine that we were not dealing with a response variable that was subjective, such as taste. Let's imagine we were dealing with a very purely objective response variable, which is the weight of the tomato. Like, let's pick a tomato off the vine, set it on a scale, record its weight. Everybody got me? In that case, I would argue there is no need for this experiment to be blind at all. Blinding is not a necessary requirement of an experiment. It's an added luxury to have if you're in a situation where you need it. But if all I'm doing is weighing the tomatoes and I'm hiring Samuel to weigh the tomatoes for me, I could care less if he knows which tomato got which, because all he's doing is putting them on a scale and recording a number. Does that make sense? I don't need to take efforts to make sure the tomatoes don't know what they got. And if all he's doing is weighing the tomatoes, I don't need to make efforts to make sure he doesn't know what the tomatoes got. Does that make sense? But if it's a subjective variable such as taste, well, then you got to worry about maybe making it single blind. Not that you have to, but you're opening yourself up to bias if you don't. Okay? All right, go ahead and turn the page. Once again, we have a semi-complicated looking printout. What I would argue is I want to give you the write-up and the picture. Both boxes give you a lot of redundant information. So take 2 minutes, just read the write-up, look over the design, and then I'm going to go through the questions at the bottom of the page. Go. All right. So I gave students a couple minutes just to read through the prompt. The idea is, the hope is that you would be able to respond to these questions relatively easily, having given the chance to read through the material. Okay, but like I said, the problems I want to give you all a chance to work ahead of me on is not here. So why is this an experiment? Again, if you give me a textbook definition, that's a great answer, but it's not full credit because it's completely devoid of context. So instead of using words like treatments and subjects, while yes, these are words you should know the meaning of, it is better to say things like fertilizer and water, because those are the treatments, were assigned to tomato plants, because those are the subjects. Okay. When you're identifying the subjects, I would urge you to not just write tomato plants. Anyone suggest what other small piece of information you could include? The letter of the alphabet. What does the letter N stand for in this class? Amount, sample size. Okay, include the fact that there were 180. Okay, now in the drawing itself, it makes it clear that you've got 6 different treatments. And that's because there are 2 different factors in play. Okay, 2 different variables. It's fertilizer amount. And when it comes to fertilizer, the write-up made it clear you're either going new fertilizer or it'll get a 50-50 mix of the two. So there are 3 possible ways that you could be quote unquote treated when it comes to fertilizer. But within each of those 3 branches, there are 2 possible ways that you're going to be treated regarding watering. Okay, you're either going to get once a day or twice a day. Now, this results in 6 different treatments because you have 2 factors, level 3 and level 2, and 3 times 2 is 6. Now, I'm going to elaborate that in just a moment, okay? But the 2 factors are fertilizer with 3 levels and water with 2 levels, okay? And that results in 6 treatments. Now, just to make sure we understand this sort of number of treatments math, okay? All you have to do is find the product of all the level numbers. So if you have one factor with 3 levels and another factor with 2 levels, all you do is multiply 3 times 2. Let me give you an example that is far more complex. Imagine we had this is a hypothetical demonstration of treatments. Imagine we'll still keep the 3 levels for fertilizer, we'll still keep the 2 levels for water. But imagine I also want to factor in pesticide. Maybe you get the pesticide or you don't, just 2 levels. You either get it or you don't, okay? And humidity, maybe I do like 25%, 50%, 70%, 100%, just to see how does different humidity levels, how do these plants and the fertilizer react? If that's the scenario you're working with, well, suddenly you have one of 3 ways to get fertilizer. And once you follow one of those 3 branches, you have 2 ways of getting water. And once you follow that branch, you have 2 ways of getting pesticide. And once you follow that branch, you have 4 ways of getting humidity. So what you have is a breakup of 3, followed by a breakup of 2, followed by a breakup of 2, followed by a breakup of 4. And so you would literally have to do 3 times 2 times 2 times 4. Now, this also, by the way, would have an impact on the sample size you would need. What I would argue is that if you only have a sample size of 180 tomato plants and you're planning an experiment with 48 different treatments, you're not giving yourself a whole lot of replication. Replication is a vocabulary term that refers to how many times are you able to actually apply the treatment. That way you can actually get a good idea of what that treatment does. Okay, in other words, if I had 48 different treatments and exactly 48 tomato plants, I'm only applying each combination of treatments once. That's not a whole lot of data. Okay, so I would argue you're going to need a much larger sample size. Okay, in the original, we had 6 different treatments, so each treatment was being applied to 30 different plants. Well, if you wanted to apply it to only, say, 20 different plants, you need 960 plants. Okay. Now, the response that's being measured is on the tail end of the design. It says growth and in ounces. It even gives you the units and color. And identify the variable by which blocking was used. Again, that's the sunlight, direct and indirect. And you're given in the write-up that because taste, it says single blind, those evaluating color, okay? Not taste, the last one was taste, this one's color, but those evaluating color are going to be blinded. Okay, if I'm going to hire people to kind of look at 2 different tomatoes and judge which one's more vibrant red, I suppose might be what you're evaluating, I don't want that person knowing which tomato got the new fertilizer and which one got the standard and which one got the 50-50 mix. I want them to be objective in their ratings of these tomatoes, okay, not in any way biased. So this is single. Those evaluating the color of the tomatoes will not know which treatment was assigned to each tomato. Now, interesting side note that doesn't have anything particularly to do with your note packet, but it's just because I found it interesting. There are ways to treat color as an objective measure because we now have photographic sensors that can detect color and do so very accurately. Here's one of the more ridiculous or impressive applications I've seen of color detection, and I'm sure there's thousands out there that I'm not even aware of. It was, again, me watching one of those Modern Marvels type shows, and this particular episode was talking about harvesting different crops. The images I'm showing you are blueberries. Okay. And what they showed was after they sort of washed the blueberries and removed the sticks and the leaves and everything, they have tens of thousands of blueberries. The image, by the way, is blurred here because the moment those blueberries hit this blue tarp, the blue tarp is like zipping by at a really high rate of speed. It just kind of whisks the blueberries away in a conveyor belt. That's why the image looks blurred over there. The blueberries are literally moving really fast. So after the blueberries have been washed and all the leaves and sticks are removed, they fall onto a conveyor belt. And on that conveyor belt is a digital scanner that is literally scanning the blueberries for color. And then what ends up happening is when the blue conveyor belt comes to an end, it flings the blueberries onto a separate ramp. So momentarily, the blueberries are suspended in midair as they're being launched across. In that particular moment, there are hundreds of miniature air cannons that are triggered based on the computer to just kind of like spit out a quick puff of air, and they're timed so that they hit all the blueberries that were detected to not be blue. Now, it's not a perfect system because you have blueberries racing by at super high rates of speed, so sometimes the air puff will hit more than one blueberry at a time. But if you notice in this bin, which is a collection bin underneath down here, like 50% of the blueberries are green. That was insane to me that, you literally had this conveyor belt that's just like whisking blueberries by at this super high rate of speed and it's just blowing them out in midair based on a computer tool that was used to detect color. It's like crazy to me that that even exists. In any case, all right. So that was just to say that if you really wanted color to be objective, you could use a computer to actually analyze color for you, and then it's an experiment that doesn't need blinding at all. Okay, again, I want to stress, blinding is not a required part of an experiment. The only required part of an experiment is, are you applying treatments randomly? That's what makes it an experiment. Okay, and that's kind of what we set up here. Why is this an experiment? Treatments were applied randomly to subjects. That's why it's an experiment. Okay. All right, go ahead and turn the page. We've got about 16 minutes left in class. So I'm thinking I'll give you 5 minutes to work ahead of me on 4.211. Just see how far you can get, work together. When the timer's up, I'll go through it, and then we're going to repeat that process for the next problem, and we'll call it a day. Get going. The answer that Maya gave was perfect. The only improvement is don't just say patients were assigned to treatments. Say patients were assigned to, and then name the actual treatments. Give that extra context. Okay? All right. Okay, so thank you for the answers that were provided so far. For scope and conclusion, basically what they're asking is, when you are done running this experiment, what kind of thing could you say? All right, so if you actually notice something worth noticing, you see something that's statistically significant, what might you conclude? So you can conclude, or you can discuss whether or not omega-3 fats from fish oils cause improvements in patients with bipolar disorder. Now, in terms of how to improve the design, can anyone suggest, and I have, I believe, 4 different possible answers for this, so there's a lot of variability here. Can anyone suggest a way that you could improve this experiment and make your conclusion a bit stronger? Make it double blind. Make sure the patients don't, I mean, the placebo takes care of single blind. The patients don't know, are they getting the oils, or are they getting something else? Okay, that's the whole point of a placebo, to blind the subjects. Okay, but it could be double blind. Make sure the doctor's evaluating them. Oh, that's why I had that image. Sorry, I had a little random thought. Okay, there was a medical study. I'll make sure I share that tomorrow. I moved an image to a later lecture, and I couldn't remember why I included it on this one, and I just realized why. All right, so you could make it double blind. Something else. You could increase the number of treatments. Absolutely. Like, don't just do a you get oil or you don't get oil. How about you get a placebo, or you get 200 milligrams, or you get 300 milligrams, or you get 500 milligrams? Like, do more varied treatments. Any others? There's one that I would argue is the most obvious. There you go. We only have 30 subjects. That's an immediate way to improve this study. Okay. So the answers I had prepared is, you could test more subjects, you could make it double blind, you could have more than 2 levels of the given factor, and the 3 of you helped out with all 3 of those. So wonderful. The other thing, as I mentioned, you could have run the test over a longer period of time. Okay? Questions? All right, so thank you to those of you who provided answers. This is our answer key to 4.212. Just commenting on the last answer, it says, no, this is an observational study. And then the rest, I'm sort of referring to the scope. The actual scope of this observational study is we could say there's an association between blood pressure and memory. But the reality is, let me move this up so people can see this. It is possible that age is a confounding variable. This is just one of many that I could come up with. Okay. And I can connect age to both of these things independently. As you get older, your memory tends to decline. As you get older, your blood pressure tends to go up. Or to put it in a different way, I would say older people tend to have higher blood pressures. Older people tend to have worse memories. So that could be something that explains the pattern we're seeing. Okay. Now, I wanted to end on a separate, very short video with you all. Okay. This is a very quick video where a guy talks about an experiment where scientists were trying to eliminate all the confounding variables they could think of. I found it very, very interesting. Okay. It's crazy to me that this actually happened. And the answer to avoid all the confounding variables, such as temperature, angle of the sun, and humidity, and just all the different things that could explain why the bees are coming out at a certain point in time, to avoid all of this, the answer was, let's teach them to do something at a specific time, then fly them across the planet, where if they really know time, you can't argue it's the angle of the sun. It's different. You can't argue it's the temperature. We're in a different zone. You can't argue it's the humidity. You can't argue any of the environmental factors are causing these bees to come out at a specific time. But when they came out at the jet lag time of 10 a.m., it was proof that they had learned time and that they actually perceived time. So this was a really quick example of just how there's a lot of effort that gets put into avoiding confounding variables. Confounding variables are nothing more than you ran an experiment, you treated things in a certain way, you measured a difference, and now you don't know, was it your treatment or was there something else that caused the response that you were measuring? That's a confounding variable. This is different from lurking variables. Okay, a confounding variable is you measured a difference and you don't know what the cause is. That's a confounding variable. That's not the same as a lurking variable, and those are two things that people get mixed up all the time. Okay? All right, I'm done. Thanks for listening. Have a good one. All right.